Greetings, the Astro 30 here again, and today I'm going to be putting together this T12 Hakko clone soldering iron. So let's have a good look at this switch mode power supply and see what we've got. Okay, I don't know who is actually lacquering circuit boards over there in China, but whoever it is, please stop. Look at that. That's uncured lacquer. It's, yeah. Anyway, a bit of cleaning with isopropyl alcohol would probably fix that up if I was that worried about it. The actual supply itself looks like it's good quality. Well, in design, they've got, I think that's an output regulator. I can't see because there's an inductor in the way. Yeah, you got a DC output with a filter capacitor which is 35 volts. So I misspoke yesterday when I said this had 38 volt output. I don't know where I got 38 volt from, but I went and rechecked the Banggood listing, and it's actually a 4 to 6 amp 24 volt DC output. So yeah, there should only be 24 volt, and in fact it says there DC 2412, so you can assume the 24 means 24 volt. Anyway, that looks like a 24 volt regulator, maybe. I don't know, can't see as I said because there's an inductor in the way. That's a chopper transistor. That's for the switch mode square wave side. That's the high to low transformer. Yeah, anyway, it's pretty simple design. There's the octocoupler right there. I believe that's the control IC right down there, a little surface mount device. But there's no earthing on the actual connection points that you screw to the chassis with, so this is actually floating earth by the looks of things. So I was also wrong when you earth the PCB to the case here. That's not going to happen unless you physically make it earthed. But yeah, first I need to choose which side of the case, because this has got a few little dings in it. This one's also got a... No, this one's actually perfectly fine. This surface looks nice and pristine, so that'll be the top. The one with the nicks in it will be the bottom. So it's going to fit together something like that. Now, of course, I need to put the front panel control board in first, so I know roughly where my alignment for mounting this is going to be, because I don't want to mount it too close to the front and have no room. So obviously I'm going to need the DC output towards the control board, and the AC input over here towards the AC socket, because if you look, that's where you mount the AC plug socket, and if it was the right way up, which is that way to the case, you'll notice it lines up with that connector. So that's where I would be putting the PCB, obviously, but I probably mount it as far back as possible. But I've also got to be careful because I have these other hardware items, such as the power jack to mount, which would mount in there somewhere like that. I would suppose you put the center lead up. I don't suppose it really matters. But that's also got to have... See, now I've got a clearance issue. It's touching that connector, so that has to come right back forward somewhere. So I can also see the power jack is going to interfere with the mounting screw of the power supply, which could be a little bit problematic. So what I first need to do is I need to work out how much space I need at the front. I already got a fair idea how much space I need at the back. So I'll get started on the front board. There's no plastic window or anything through where the display goes. So it mounts something along the lines like that. And there's your connector plug there and your LED and the calibrate pot, which, by the way, I don't even have a calibration pot. Huh. Well, that's interesting. So there is no calibration pot on this board, even though they've got a hole for calibration. Well, that's disappointing. So if the temperature's out, the temperature's out. So yeah, I don't know what you're supposed to do if the temperature's out. Well, that's annoying. Anyway, there's nowhere for a calibrate pot. Anyway, so that's going to mount something like that, so I can afford to bring that board forward as much as possible. Then we get our rear panel, which I might actually put the screws in for the AC socket. See, they haven't really thought this out well enough. No way, shape or form have they thought this out well enough. For fuck's sake, will you stay still, for hell's sake? Right, so that's the AC socket mounted in. So now I know that's going to stay where I put it. I'm still not liking how that's coming together there. Not at all. I can't really move it over much either. Well, I suppose I could, but it'd be... As I say, it would have been nice if they pre-drilled all this first, so that, you know, we don't have to like try and figure this stuff out. Because a lot of the time I hate having to think. So I need the, well, I need that as well, but I don't need that. I need that. That's the connector plug. So I'm just going to mount the whatever it's called. Now I'm just going to mount the, I haven't taken off the protective film yet, I'll do that shortly, but I'm just going to temporarily mount the rotary encoder to the front panel so it stops it moving around. I haven't even tightened it yet. I'm not liking that. Nothing on this, nothing fits. Okay, so this just gives me an idea. I mean, yeah, that's very, very, very close to the mounting points. Yeah, that's not good at all. This is turning out to be a total nightmare. I mean, I'm not liking that those standoffs are anywhere near the AC input. That's just bad, because the only way I'm going to mount this board is to drill some holes once I figure out where I've got to put it, and put a M3 screw up through it. I believe I can use M3. You know, I could use M4 if I wanted to, but that's getting a bit big. A nut on the other side down to the metal, and then 4 of them around the holes just to prop it up a few millimetre, and then nuts on the top and washers probably, just so I've got clearance from the top panel. But as it stands, I'm not liking this at all. Okay, so I've turned the AC inlet round the other way, 180 degrees, so at least it's the earth terminal that's going to interfere with either one of these standoffs, which won't be too much of a problem because that's already at earth potential. Now I'm going to install this switch into the back panel, and because I'm Australian, up is on to us, off is down, so that's the way I'm going to install it. That's just the way we are. Yes, we're backwards. So it's just a simple matter of squeezing it in like that until it snaps, and now we have a switch. Now the live terminal is over here on my left or the right of screen, so that will go a wire from here to here, from here back to the power supply, here back to the power supply, that to the case, and that's all I need to do there after throwing it away. So I'm still wondering about this issue of the front panel. I can see the issue. Now I can see why the front panel's at an angle. There's a little locator pin on the rotary encoder which is interfering with the front panel, obviously. Now I don't see in the bag of components any other sort of spacer, shim or whatever for this rotary encoder. So what I'm going to do is I'm just going to simply bend that over out of the way so it's not making contact with the back of the front panel anymore. Although there is a height difference between here and here, but I'm just wondering if this display pops through the hole. So if I put the thing the right way around might help. Yeah, there's a real big alignment issue here. So I'm going to need to shim that rotary encoder with something. A shake-proof washer would work a lot more effectively, but I don't have one. They didn't supply one. So yeah, but now I've got to work out, does this pass through the front panel first, then to the board, or is it the other way around? So I'm pretty sure it's the other way around. Now on this board they've got a little bump here which represents earth, which will also represent that little notch at the top of the connector, which means that that's that way that goes around. So then this would pass over the top. Yeah, that seems much more logical. I'm still going to need to find a shim for the back of that rotary encoder, but I'll come to that in a sec. I just wanted to see how this all fits together. So I know it fits that way around. The markings are on the back as well as the front for what is what. So what would be a good idea is, before soldering anything, is to write down this legend. So when you come to wire the wires to the cable and the plug to the handle, it would make it a lot easier. So I'm going to do that now. Positive, that's a ground. That I think is just no connection. And that one is the earth. Okay. When I was speaking about the earth, by the way, they got E marked over here. This would be what's actually earthed to the case, not the ground connection, that's the negative rail, but you would earth this, which is going to earth the soldering iron to the case. Now there is a trace. There is no trace that I can see that comes off of this E connection going anywhere. Not on either side, so this is just open. This is what I was talking about. This has to be grounded to the case, otherwise it's not going to ground the iron or earth the iron. And coincidentally, these pot nuts and pot washers are the right size for the rotary encoder. They're the same. The same size, same thread pitch, so if I wanted to I can even use the same nut. However, I've just put two of them on the back of the rotary encoder, or the base of the rotary encoder, and now I have got just enough clearance from the front panel and the rotary encoder, so it's no longer sitting in midair. So that means that solved that problem. I can always replace the pot washers with something else later. It's not that great big of a deal. So I guess what we need to do is I'm also going to put the LED in the correct way around. There's a long lead and a short lead. The short lead is negative So I'm going to pass that through the board as well, but not solder it yet because that's got to line up with the front panel. So that goes in there, and I'll take off this protective film. Otherwise it's going to be a little bit problematic later. I'm also going to insert the socket, marry up the front panel, and I suppose for the final time I can screw the rotary encoder on. Yeah, that looks about right. So I'll also put this nut on for the socket and get it started, but I won't tighten it because I've got to solder it first before I try and tighten it, because you've got quite a fair amount of gap in between the two, where the base of that is and where the back of the front panel is, so you don't want to pull that too tight or you'll bend the panel. But that's only just there to sort of like hold the panel against it. It's not there to actually hold the socket still. So that's basically what I was going for. Now that looks nice, it's reasonably straight. So I'll just tighten up the rotary encoder and we can move on. It's starting to look like something now. Now I'm not sure, there's this part in this bag here. I'm not sure what that is. I think that goes inside the soldering iron handle. Now, yeah, I reckon it goes here. See, there's a footprint here for something that looks like that. So that would go there. And this is all before I've soldered something. Now, this is the tip I'm going to be using. We're just going to have a look at how this actually works. That goes in there like that, goes past the contact, and goes all the way down to the base of that board. As you can see, we've got contacts here and here, and a contact here. So that would be the ground connection, and this would be the actual heating element connection, because this whole entire tip is actually the heating element. Now it's not diode, so I don't know what that is. Maybe it's time to consult the instructions. When in doubt, C4. No. Let's see here. Well, we can see by the badly photocopied crap here, we can just see that part going through two holes. As you look at with the long part of the circuit board that sticks out facing to the left, it goes in the bottom most holes, and I don't think it's a polarized component. However, there on this component there's a black end that's not as prominent as the red end, and this looks like where the red end is, and this looks like where the black end is. So I'm assuming this is denoting that that's positive and that's negative. I'm not sure what it is. As you look at this board with that facing to the left, it goes across there. So I don't think there's any real polarity to this, but well, if it doesn't work, we'll soon know why. So I'm just going to bend the leads of this, and I'm going to put it in the circuit board where it goes, just so I don't lose it. And yeah, that'll get soldered in shortly when I go to start soldering. But really, practically speaking, and I've just looked at this, this display is crooked, and that's a shame. Anyway, now I want to work out where everything's got to go. So, yeah, I reckon it's going to be something like that. I've lost the back panel. Something like that. Yeah, I reckon I'd get away with that, to be honest. So if that circuit board was sitting dead central, back to front, side to side, that won't be a problem. So I'll keep that in mind. First, what I'm going to do is I'm going to plug in a soldering iron and warm it up, and I'm going to first solder the LED now that it's in roughly where the place it should be, and solder this socket in so it's not flapping around. And just out of interest, this soldering iron stand that I'm using currently, this is also part of it. This was actually designed for this soldering iron kit, but it doesn't have any feet on the bottom of it. I had to supply my own, so just keep that in mind or else it's going to slide around the desk. The case, they have provided some self-adhesive feet that you stick on the bottom, so that was nice, but it would have been nice if this had some, but it doesn't. So I'm just waiting for my soldering iron to warm up. As I said, it's ironic you need a soldering iron to build a soldering iron. Now, interestingly, they haven't soldered the ends of the rotary encoder there, the tabs, which is interesting. So I will probably start by soldering that. So I'm going to leave the circuit board in whilst I start marking the holes. That one's going to be way off. I want you down here. There we go. It's the holes drilled. That was for the secondary side, the ones closest to the front of the secondary. And yeah, they don't line up too bad, so now I can get some bolts and nuts. So with that tight now, before I do anything else, so I'm not scratching the crap out of the desk, is I'm going to put the little supplied rubber feet on. And I'll just place them, you know, close to the edge there. It's not really a big deal where you put it, you can put it anywhere you like. Stick it to the end of your nose for all that mattered. So, that's the primary. So I'm going to need a tag for earth. So what I might do is I'll use one of these eyelets that I've got, bend him up, and I'll stick it on one end of the circuit board. This is pretty much what they do in commercial electronics anyway. So I'll just tighten the nuts. I'll keep that over a little bit so it's not touching anything at the back. Actually, I'm just going to make sure that the switch isn't interfering with that, which currently it is. Okay, so that means I either move it or I just turn him around. So I'll just turn it around. Okay, so the next thing I'm going to do is wire up the AC live to the switch to one terminal over here, which I'm not sure how these terminals work yet. It's a connector I haven't quite seen before. Looks like they're like a push type connector. You push the end in, which opens the tab, or pull it, maybe. You push it down like that, which would open the gripping contacts, and then pass your wire through the hole and then release the clamp and it should hold it. Well, that's the theory anyway. So anyway, I'm just going to wire it all up and the earth, and then I'm going to plug a power plug in and actually do a first power on smoke test. Okay, got some progress. I've got the switch wired up, the active wire going in, active wire coming out, and the neutral wire. So that's just going to sit there like that, and then we just make things fit. So all I've got to do now is wire the earth wire onto the earth tag, and then we can test it out. Okay, they're in like Flynn, I don't think it really matters which way around you put it. But, just have to like bend all the wires to make them agree with each other, so that when it's screwed together it fits nicely. Now to put the plug in and see if it blows up. However, what I might do first is I might actually screw the panel on there, so I'm not putting a stress on it with the power cable. Okay, I've got it plugged into a power board on the floor with a safety cutout switch on it, surge protector switch. So I don't really want to be facing this when turning it on. Okay. Well, there's a little green LED that came on just down here. Be careful when touching around near heat sinks in here because one of them may be live. I'm not using an isolation transformer, which I probably should. So I'm just going to measure the DC output voltage and see what we get. 23.7, 23.8, close to 24. So the power supply is working. So now I can move on to the next part, which is thinking about hooking up the front panel to the power supply. There's a positive mark here and a negative mark there. They just go to the DC outputs on the circuit board, and Bob's your Arnie. Okay, I ended up using their one hung low cheap crappy wires because I couldn't find anything suitable. Both boards are connected now, so I'm going to plug it in and do a power on test. Well, there we go. It comes up by default as 500. Now it's not going to do anything because, well, the handle is not connected. So I now know that this circuit board is doing what it's supposed to be doing. It'll be mounted to the front like that. So now I can move on to the probably what we could consider the hardest part, which is actually doing the handle. So after just gently going around with a utility knife and stripping off the ends of the wire, the insulation, I've got 5 strands. I've got a red, a green, a yellow, a black and a blue. Red can be for positive, that's marked. Black can be for negative, that's marked. Green can be for ground, that's also marked with a ground terminal. Yellow and blue are the other 2 remaining leads, which is A and B, but I've got to figure out which way around goes what. Okay, I believe I figured it out. Where I said there was no connection there on that one, that's actually the negative on the socket. My bad. Anyhow, the colour coding I'm going to use is pretty simple. I actually already looked at Volt Log's video because he's actually made a PDF which gives you a wiring diagram of how to wire the handle to the socket, or the cable. So he's got it black here for the negative, green for earth, red for positive, white for the switch line, and for the ground, blue. Okay, and on the handle board, we're actually going to be wiring on these terminals here rather than the holes. So on these terminals, these strips of these, whatever you call these pads, here is where we're going to be soldering the wires. So it's going to go red, A is blue, green is the center one, white is B, and black down the bottom is negative. So that's the way it's going to be wired, and that's exactly the way I'm going to wire it. And of course there is no white wire in there, so we'll just change that to yellow. So substitute white for yellow. So that's the the handle complete. I don't have to do anything more with that except slip it in to its home. So there's 2 notches, 2 little cutouts, or whatever you want to call them, in the side of the handle here that you've got to get the board to go into, and this thing is just not wanting to behave itself and go where I wanted to put it. Plus I can't see. So that's got to feed into there. Right, so, and that's about as far as it goes. So that's now in there. I can now screw this part on till it's tight. I'll grab my tip. I believe that's as far as it goes. Screw on the butt. And there we go. That's the actual soldering iron handle itself. All nicely done. So now what I've got to do is wire the plug on. Now after unscrewing the socket part from the outer part, we need to obviously pass our cable. This is the clamp side of the cable. So we need to pass it on our cable first, because if we solder this on, we are not going to get it on later. So, and this is going to be probably fairly challenging to solder, but yeah, just take your time and just keep an eye on what your orientation actually is. Okay, so that's the socket soldered. The wires are soldered on, so I can bring my other end back up to it and attempt to screw that back on without cross-threading it. There we go. The other important piece of this, which is the clamp and the two screws to hold the clamp together. So I need to put that on there. Grab a little nut, a little bolt. And I need a smallish screwdriver for this. I think this might be too small. And that'll do the job. Let's get that one started first. And all that is just a strain relief. It stops the cable from being pulled back out of the plug. Okay, so now that I've got that done, I can hook it up to the soldering iron control and see if we can A, vary the temperature, and B, how accurate it is. So I'll just screw that on. Now, I'm just going to leave that dangling in the breeze because I've got nowhere to put it at the moment, because the other soldering iron is using the stand. So the thing they say with these brand new tips is not to bring them up to full temperature quickly, bring them up slowly. So start at something like 100 degrees and then raise it to the final 360 in several increments. I'm not sure why. It's probably to burn off anything manufacturing stuff on the front of it or whatever. So, moment of truth, turn him on. And it's slowly coming up temperature, so I'm going to drop it. It's set to 300 and something, so I've set it to 200. And I did see some smoke come off of something there a minute ago, but I reckon that was because it's burning off some chemicals on the front of the iron. It is actually heating up. I can smell it. So I'm just going to grab one of these. This is a surface or body temperature gauge. I'm going to see what the temperature at the tip is. I know this is upside down. Apparently 39 degrees. So I've just got to let that warm up. Although it is melting solder. Now it says it's 28 degrees. Maybe if I measure it right at the tip. 22 degrees. I don't think this thing is accurate. I mean, without a calibrate pot on this can't be that far out. 360 degrees according to the display. According to the thermometer, it's still around 29 degrees. I'm not trusting the accuracy of this thing. So I have brought the temperature on the tip up gradually. I haven't actually brought it up all of a sudden, so, but it's hot enough to melt solder, so I know it's working. It's hot enough to burn, but it doesn't feel like it's heating up a lot. Yeah, I can kind of leave my finger on that base here quite a long time. I got 85 there a minute ago. $91, $90. Yeah, I had to put the soldering iron right in the hole, but I do know that this is a lot colder than this. And that's 91 degrees Celsius, which is what I got roughly out of it. And it reckons the temperature is 400 and something, which is doubtful. How high can this thing go anyway? 450 is the maximum. So at 450 maximum on this thing, I mean, it is enough to melt the solder, but we're only getting around about 90 odd degrees Celsius in there, which is kind of depressing. And if I can do that to the butt of the soldering iron, and it's not that annoying, it's not getting that hot. Ah, yeah, but the tip's hotter than the fucking... Oh, yeah. Yeah, the tip of the iron is definitely hotter than the butt of the iron. I think that's by design. So I know the tip is getting quite hot. Yeah, it's enough to melt solder and to really burn my skin. So I know that that's working, albeit not very accurately, but it's working. So I'll just solder that directly to the flux capacitor. I've got to stop saying that. Directly to the back of the connector there, and I'll just make him about that long. Not really particularly worried here, and I just need to go grab another eyelet, and then I will solder it to an eyelet. To earth the thing. Soldering capacitor. I mean, frickin' things in the way. Note to Chinese people, design modules like this, do not put mounting holes relatively close to other components. Have some clearance, and if you do actually make a prototype, stupid thing, if you do actually make a prototype of this product, double check that you can actually get nuts that size in there, because, well, you've drilled them out to 4mm holes, so I'd expect to be able to fit a 4mm nut on there. Good luck with that. I would never have been able to do that, so don't over tighten it, because you will strip it. Okay, that's done. Done like a dog's dinner. Okay, so that's the Hakko T12 clone. This is actually a DSK T12-D temperature controlled soldering iron kit from Banggood.com. Am I impressed with the results? Well, electronically, yes. Assembly wise, a little bit vague. Operation wise, no, not particularly. My soldering iron, which is a 25-watt soldering iron, has a temperature well over 160 degrees. This says it's at 460, but this thing says that it's at, 91 maximum. But see, the problem with this is it's actually designed to measure body temperature. So well, that was a fail. F2. I think that's Fahrenheit, sorry. That might be what's going on here. Right, see, it's designed to measure body temperature, and currently it says that I'm at 36 degrees. So it says I'm at 36.1 degrees. That's what it's designed to, and the mode you've got is like surface, so you can measure the temperature of a sleeping baby without, you know, being too invasive, but you've got to be really close to do it. And see, it says it's 31 at surface temperature. Body temperature is 36, which is where it should be, so I don't think this thing is very accurate at all. So I would trust the reading on this like I would trust a Catholic priest. Yeah, this is saying it's at around about 430 degrees. I believe that's in Celsius, and that's at its max, 450. But it's hot enough to, well, burn my skin, which it did, and hot enough to melt solder. Is it hot enough to solder a soldering joint on a circuit board, for instance? Well, yeah, it should be. So for giggles here, I'm going to take my potentiometer that I desoldered the wires from, and I'm going to solder some wires back onto it. See if this thing actually does work. Well, I managed to bridge that joint, which is what I want. So I will... Well, would you look at that? It actually does solder. Joint's not too bad either. It did actually solder, and the joint's not terrible. So yeah, okay, the results are relatively impressive, but for $58 for all of it, compared to paying, you know, anywhere in excess of $400 for a good temperature controlled soldering iron, you get what you pay for. I reckon that this, temperature wise, is going to be operating at around about 15 watts compared to a 15 watt soldering iron. So yeah, it's only going to be designed for low soldering work. There's no way that this temperature gauge is accurate. Yeah, but it is what it is. Anyway, that's it for that. Thank you for watching. I'm the Astro 30, and if you enjoyed this video, please remember to rate, comment and subscribe below, and you can always follow me on Facebook and Twitter. The links are in the description as usual. Also, you can support me on PayPal by donating as little or as much as you want, because your donation allows me to buy stuff to play around with on the channel. And speaking of channels, check out this guy, 12 Volt Vids. He has some great content to do with electronics on his channel. Anyway, this is the Astro 30 saying see ya, have a great day.